Hello, good evening, friend. Today I'm going to discuss the some of the exercise problem. This is the Intext problem, exercise problem of the surface chemistry. Let us see what are the problem. If you see the Intext problem 5.1, so what they are saying in the surface chemistry, that is, write any two characteristics of chemical absorption. Okay. So dear student, they are talking about the chemical absorption, and you know very well that chemical adsorption are formed by the what that is the in which that is there is the force of attraction exerting between adsorbent and adsorbent is the chemical bond. Like, what are the chemical bond, student? That can be the covalent bond or ionic bond or any other bond. So they are asking, that is, any write any two characteristics of the chemical absorption. So there are so many characteristics, but when you are going to talk about, so some first characteristic is the chemical absorption is highly specific in nature. Dear friend, why it is specific in nature? You know that is in the chemical absorption. What is happening, student? You will find there is the new bond form, new chemical bond form. New chemical bond result in the formation of new product. So what will happen? New product. So it will be what is? It will be the highly specific, and it occur only if there is a possibilities of chemical bonding between the adsorbent and adsorbate. So that is, if any product, every product is what that is specific in nature. That is why chemical adsorption is what is, student? That is the highly specific. While when you are talking about the physical adsorption, student, there is the physical bond is there. So that physical bond is reversible. Like that, water is vaporized and then then will condense. So physical adsorption is not the specific. Now the second point, when you are like physical absorption, chemical absorption also increases with increase in the surface area of the adsorbent. So what the second point is, student? When you are taking the fine powder, okay? So fine powder, if you are taking, student, so you will find that is the surface area of the adsorbent, that is surface will increase, fine powder. So that is why, that is, if the more the surface area, more the adsorption. So that is that these are the two characteristic. If you talk about the some more characteristic, student, that is, if the heat of adsorption is quite higher, student, this is the 80 to 240 kilojoule per mole. And other things, when you are talking about, student, in the chemical absorption, so chemical absorption is already given, that is, this is a irreversible in nature. Chemical absorption is irreversible, while the physical absorption is reversible. Why chemical absorption is irreversible, student? Because of the new product form. This is the chemical process. Chemical processes are always irreversible. Now let us move for the another question number 2. What is the Intext problem 5.2? What is there, student? If you check out, they are saying that is, why does physical absorption decreases with increase in temperature? Dear student, that is, if you talk about physical absorption is always exothermic process. It means, that is, when you are when the adsorption takes place, the that is the residual force getting decreases. A residual gas force getting decreases, it means there is the some release of energy taking place, residual energy. So this process, physical absorption, become the exothermic. So what will happen, student? Why does the physical absorption decreases with increase in temperature? So since it is a exothermic process, and according to Le-Chatelier principle, for the exothermic reaction, when you are increasing the temperature, the reaction will go backward direction. This means physical absorption will be more readily at the at lower temperature. What do you mean by this, more readily at lower temperature? It means that is the exothermic process. Whatever the exothermic reactions are there, if you are increasing the temperature, so product side temperature will increase, so all will go in the reverse direction. So desorption will take place. So that is, physical absorption will decrease at high temperature. I hope this will be, you people may be knowing with the Le-Chatelier principle, student. Why? Because the Le-Chatelier principle is saying that is the equilibrium will shift in that direction where the effect is minimized. So if it is going the backward direction, so temperature will be low. Means the physical absorption is exothermic process, and when you are decreasing the temperature, the process will be high. So that is, you can write, students, since it is exothermic process, therefore on increasing the temperature, the physical absorption decreases. Now let us move on to the question number 3. What is question number 3, student? That is Intext problem. Why are powder substance more effective adsorbent than their crystalline form? Dear student, in the powder substance, when you are talking about powder substance, they are having the high surface area. Powder substance are having high surface area, so therefore that is the adsorption will be also high. You can read out the answers what is given in this PDF. Powder substances are more effective adsorbent than their crystalline form, because when a substance is powder, when the substance is powder, its surface area increases, and physisorption is directly proportional to the surface area of the adsorbent. So when the surface area increases, friend, so what is happening? You can check it out. What is happening? If you check, you will find that is when the physisorption is increases. So what you are finding, student, you are finding that is the surface area increases, means more the gaseous molecule will be able to get adsorbed on the surface. So therefore physisorption will be increases on the increasing in the surface area. Now let us move for the another point, student. What are the other point? Let us check out. When you are going for the other point, friend. So other points are question number 5.4. Let us read out. Let me shift this camera, student, because this camera is quite little moving up and down. So 1 minute please. How can we shift this camera? Hold on please. Now let us move the another problem, student. What is the another problem if we talk about 5.4? So fourth number question from the Intext. What is there? Why it is necessary to remove carbon monoxide when ammonia is obtained by the Haber process? So this is very important, very easy also, student. So in the Haber process, okay, in the Haber process, when the nitrogen and hydrogen is taken for the production of ammonia, at the same time what is happening, student, you will find that there is the formation of carbon monoxide also getting adsorbed. So carbon monoxide is it's a catalyst poison. Since it is catalyst poison, that is why its removal is always compulsory to remove, because it is acting as a catalyst poison. It decreases the activity of catalyst. Therefore what we do is, student, that is we remove the carbon monoxide. So what the slides is saying, so it is important to remove the carbon monoxide in the synthesis of ammonia, as CO adversely affect the activity of the iron catalyst used in the Haber process. So its correct answer, student, in the slide it's not mentioned properly. In the slides what we can say, that is CO is acting as a catalyst poison, that is why we remove this as carbon monoxide in the process. Now let us move for the another problem, student. What is the another 5.5? Why it is ester? Why is the ester hydrolysis slow in the beginning and become faster after the some time? So question number 5 point, it is example of autocatalysis, student, and this example is quite very important. So let us read out the answers. When you are taking that is hydrolysis of ester, student, so ester you take and react with the water, so you will get that is acetic acid, okay, and alcohol. This acid produced, student, will act as a catalyst. So read out the slide, student. The acid produced in the reaction act as a catalyst and make the reaction faster. Substance that act as a catalyst in the same reaction in which they are obtained are known as autocatalysts. So when you are answering this problem, student, so that is when you are studying the catalysis of the ester, hydrolysis of ester, you are getting two things. What you are getting, student? You are getting the acetic acid and alcohol. So acetic acid is acting as a catalyst, so it will enhance the rate of reaction, and this increasing the rate of reaction is also known as autocatalysis. Now let us move, student. If you are moving the next problem, what you will find, student, why is the role of desorption in the process of catalysis? Dear student, this is also quite important problem we studied during the lecture also. That is when the catalyst desorption means desorption means this is the reverse of adsorption. Desorption is reverse of adsorption. So what it is doing is, student, if you talk about what it is doing, this desorption is what it is doing. It is the process of removal of adsorbed gases from the surface of the catalyst, So what is happening, student, what is happening in this place, that is when you remove the adsorbed substance, there will be the free surface will be there for the adsorption of new gases. So it is important to remove the gases. So what is the role? Again, you can read out this one, student. The role of desorption in the process of catalyst is to make the surface of the solid catalyst, okay, free for the fresh adsorption of the reactant on the surface. So that is the same they are saying, student. That is once you are what we are doing is, student, once your desorption is taking place, means gas will get removed from the surface. So gas, once it is removed, so it will give the free surface area for the new reactant to get adsorbed on the surface. Okay, now let us move on the 5.7, student. Let us read what is 5. Student, now the next problem is 5.7. So 5.7, this is the Intext problem. So what they are saying, what modification can you suggest in the Hardy-Sulz law? Okay, so dear student, Hardy-Sulz law, what it is saying, that is greater the charge, greater will be the coagulation power. Greater the charge, greater will be the coagulation power, and nothing more information it is given by the Hardy-Sulz. So when you are going to study, student, Hardy-Sulz rule, so what you will find, that is only this law is given, that is greater the charge, greater is the coagulation power. But what modification you can say, they did not discuss, that is the charge of the ionic radius also. But when you suggest for this one, if the smaller size of the cation is there, student, smaller size of the cation, so that is more will be polarizing power, and if more will be polarizing power, student, so what will happen, that is the coagulation will be more. So let us read out the slides, student. Hardy-Sulz law state that the greater the valence of the flocculating ion added, the greater it is the power to cause the precipitation. Flocculating ion means whatever the electrolyte you are adding in the colloidal solution. Now let us move next para. This takes place, this law takes into consideration only charge carried by ion, not its size. The smaller the size of an ion, the more will be polarizing power. Thus Hardy-Sulz law can be modified in the term of polarizing power of the flocculating ion. Thus the modified Hardy-Sulz law can be stated as the greater the polarizing power of the flocculating ion, added to the greater its power will be cause precipitation. So what is meaning of this, student? Like that we study, that is Al3 plus more coagulating power than the Mg2 plus then Na plus. So what they are saying, if you take this consideration in the if you are taking the some other factor like that size, so greater the size, student, that is small, if the size is greater, flocculation will be less, coagulation will be less. But if the size of the ions will be very small, there will be high polarizing power, and if high polarizing power, it means adsorption will be, coagulation will be very high. Now let us move to student 5.8. What is the why it is essential to wash the precipitate with water before estimating its quantitatively? Of estimation quantitatively, student, it means that is you are estimating the quantity, that is how much amount is formed. Now student, what I am saying in this one, when you are going to study this problem, so this problem is saying that is the whatever the precipitate is there, sometimes it's adsorbed with the moisture, sometimes it's adsorbed with the different gases. So what we have to do, that is when you are measuring quantity, this adsorb the unwanted things we have to wash out. Okay, so that is why it is advised always to wash the precipitate before the estimation quantitatively. So what they are saying, when a substance get precipitated, some ion that combine to form precipitate get adsorbed on the surface of the precipitate. Means some different ion which is not required, they are getting adsorbed on the surface. Therefore, becomes important to wash the precipitate before estimating quantitatively in order to remove these gases, ions or other such impurities. Dear student, because you are measuring quantitatively, if you are not removing the adsorbed substance, what will be happening? That is more number of, if you are measuring this, so what will happen is, student, it is possible that amount quantity will be high, but that is not the required precipitate. That is what we are saying. If unwanted ions or unwanted getting substance are getting a job on the surface of catalyst, so that has to be removed. That has to be removed. Okay, so that you will get the exact quantitatively answers. Now let us move for the another. So what is the question? Next one. This is the Intext problem over, student. Now we are going for the exercise problem. And exercise problem we are going 5.1. So exercise problem. So they are saying distinguish between the meaning of term adsorption and absorption. Dear student, that is in the lecture I already explained. That is adsorption is the surface phenomena. Adsorption is the surface phenomena, while the absorption is the bulk phenomena. Means in the adsorption all the molecule will be adsorbed only on the surface. Like for example, if we are writing on the chalk, writing by chalk on the board, this is only adsorption. Okay, the color is not going inside. Okay, this is the only adsorption. If you talk about the absorption, if the whatever the adsorbate is there, student, whatever the adsorbate, if it is going inside, complete getting dissolved inside of the whole system, then that will be known as what? Absorption. So absorption is bulk phenomena. Let us read out the what is slide is saying, student. Adsorption is the surface phenomena of accumulation of molecule of the substance at the surface rather than in the bulk of a solid. The substance that get adsorbed is called adsorbate, and the substance on whose surface the adsorption takes place is called adsorbent. Here the concentration of adsorbate on the surface of the adsorbent increases. In adsorption, the substance gets concentrated at the surface only. It does not penetrate through the surface to the bulk of the solid, liquid. For example, when we dip the chalk stick into the ink solution, only its surface become color. Okay, if it break the chalk stick, it would be found to be white from inside. So what they are saying is, student, they are saying that is adsorption is the surface phenomena. Only the concentration is getting adsorbed on the surface, not in the inside. Like what they are saying, that is one example they are explaining in the slide. If you are taking the chalk and you are dipping in the ink, so what you will find, student, that is the color is only on the surface. If you break the chalk, you will find inside is the white. So that is, the adsorption of the ink on the chalk surface is what is, that is, adsorption, not the absorption. Now next, on the other hand, the process of absorption is the bulk phenomena. In absorption, the substance get uniformly distributed throughout the bulk of the solid and liquid. So it is completely getting adsorbed throughout the system. Now let us move the 5.2, student. What is exercise number 5.2? What is the difference between physisorption and chemisorption? This is exercise 2. Student, physisorption means that is physical adsorption. Chemisorption means chemical adsorption. Physical adsorption means force of attraction between adsorbate and adsorbent will be the van der Waals force of attraction, and chemisorption means force of attraction will be, that is, covalent bond or ionic bond. Now let us read out the one by one from the slides. So first problem they are saying, first point, in this type of adsorption, the adsorbate is attracted to the surface by the adsorbent with weak van der Waals force of attraction. Here what is there in chemisorption? In this type of adsorption, a strong chemical bond are formed between the adsorbate and the surface of the adsorbate. So here is the first point, student, physisorption and chemisorption. Now let us move for the second point, student. The new compound is formed in this process. No new compound is formed. In the physisorption, student, there is no new compound is formed because it is the physical process. Only phase will change, like ice will convert into water, or water will convert into vapor. But here is no new compound is formed. Now new compound is formed at the surface of adsorbent. When the gas will adsorb, students, suppose hydrogen gas is getting adsorbed, chlorine gas is adsorbed, so there is possibility there is the chemical reaction taking place, and that is hydrogen chlorine take place, and that is hydrogen chloride gas can be formed. So in chemisorption new product will form, but in the physisorption no new product will form. If you come for the third point, student, it is generally found to be reversible in nature. Physical adsorption is, there is a physical process, and physical process is always reversible. Means the product will convert into reactant, reactant will convert into product. Simple example is water can be converted into the ice and ice will convert into the water, so reversible. And it is usually irreversible in nature, means it is one way process. Why it is one way process, student? The reason is one way process because what is the reason, student? The it is new product is forming, like I know milk is converting into curd, so curd again cannot convert into milk, so it is the irreversible process, one way process. Now let's move to point number 4, student. What you will find point number 4, what they are saying point number 4, student. Point number 4 is saying the enthalpy of adsorption is low as weak van der Waals force of attraction are involved. The values lies in the range of 20 to 40 kilojoule. That is correct, student. That is the physics option. In the physics option, it is weak van der Waals forces are there. So due to weak van der Waals forces, its energy, okay, energy enthalpy of adsorption will be 20 to 40 kilojoule energy will release. When you are talking about chemical option, student, it is the enthalpy of adsorption is high as the chemical bond are formed. The value is range for here, the value is written wrong, student. Its value is the 80 to 220 kilojoule. It is not 40 to 400. It is the 80 to 220 kilojoule per mole. Means it is the 40 to 400 is wrong, student. Here you can correct it out. That is 80 to 240 kilojoule per mole is there. But it is the enthalpy of adsorption which high as compared to physics option. Now let us move for the 5 point. It is favored by the low temperature condition. Means physics option prefer the low temperature condition, student, but it is preferred high temperature condition. Now last point, student, point number 6, if you check. So what point number 6 they are saying, student? It is an example of multi-layer formation. Physical adsorption can form the multi-layer, student, but when you are talking about the chemical adsorption, it is the always monolayer. No multi-layer will be formed. Now let us move for the question number 5.3 exercise problem, student. What they are saying, give a reason why a finely divided substance is more effective as an adsorbent. Okay, so they are saying finely divided substance more effective. Dear student, I told you so many times, that is when the fine powder you are taking, the surface area will be high, and greater the surface area, greater the adsorption. Now let us read out the slide, student, what they are saying. Adsorption is the surface phenomena. Adsorption is the surface phenomena. Therefore, adsorption is directly proportional to surface area. A finely divided substance has large surface area. Both physics option and chemical option increases with increase in the surface area. Hence, finely divided substance behave as a good adsorbent. Dear student, fine powder is having the greater surface area, and greater surface area is what is the proportional to greater adsorption. So that is why the finely divided substance is more effective adsorbent than the crystalline solid. Now let us move, student, 5.4. What they are saying, what are the factors which influence the adsorption of a gas on a solid? Okay, so dear student, this is also quite important. There are the various factors that affect the rate of adsorption of a gas on the solid. First factor, if you go, nature of the gas. Okay, so nature of the gas, when you are talking, student, nature of the gas, what you will find, easily liquefiable gases such as ammonia and HCl are adsorbed to a great extent. Okay, means if you are talking about the adsorption, student, those gases which are easily liquefiable means that can be converted into liquid, are adsorb great extent in the comparison to gases such as H2, O2, etc. Hydrogen, oxygen, they cannot take liquefied easily, student, so they are less adsorbed. This is behave as a van der Waals force of stronger in the easily liquefiable gas. Means when the gases are those gases which are liquefied easily, they have the greater adsorption. Okay, greater adsorption, or you can say greater force of attraction. That is why this is the adsorption is on the solid, adsorption of gas on a solid surface is also depending on the nature of the gas. Next point is their surface area of the solid. Greater the surface area, greater will be the adsorption. Okay, so greater the surface area of the adsorbent, greater is the adsorption of gas on the solid surface. Means fine powder, if you are taking fine powder, student, you will find that its adsorption is very high. Now let us move point number 4, student, effect of pressure. So adsorption is the reversible process, and is accompanied by a decrease in pressure. Therefore, adsorption increases with increase in the pressure. So, dear student, what I am saying, that is whether the chemi absorption is there or physics absorption is there, both the adsorption, both type of adsorption getting increase with increase in the pressure. Now, effect of temperature. Adsorption is a exothermic process. Dear student, when you are talking about the physics option, chemi option, it is this different, student. Where adsorption is exothermic process, then according to Le-Chatelier principle, if you are increasing the temperature, the process will decrease. So it will magnitude of adsorption decrease with increase in the temperature. So this is all about the 5.4. Now let us move for the next one, question number 5 point. What they are saying, student, what is an adsorption isotherm? Describe the Friendly's adsorption isotherm. Dear student, adsorption isotherm is the same temperature. Therm means graph. Okay, isotherm. Okay, isotherm, they are saying the graph between the adsorption and pressure at constant temperature is known as adsorption isotherm. The graph between the pressure and adsorption at constant temperature is known as adsorption isotherm. They are saying describe the Friendly's adsorption isotherm. So dear student, Friendly's give the empirical relation between the extent of adsorption and pressure at constant temperature. So what they have given, student, they have given x by m, extent of adsorption is equal to kp, p power 1 by n. Okay, here they are saying the plot between the extent of adsorption x by m against the pressure of the gas p at constant temperature T is called adsorption isotherm. Now Friendly's adsorption isotherm, you read out, student, what they are saying. Friendly's is saying that is isotherm give an empirical relation between quantity of gas adsorbed by the unit mass of solid adsorbent and the pressure at a specific temperature. So they are saying from the given plot it is clear that pressure and x by m, extent of adsorption, reaches the maximum value Ps if it is called saturated pressure. Three cases arises from the graph. What the three cases are there, student? At low pressure, if you talk about the low pressure, student, so low pressure is there. So at the low pressure, the plot is a straight and sloping indicate that is pressure is directly proportional to x by m. Means if the pressure is low is there, so adsorption is proportional to pressure. Okay, now the case number 2, if you go at high pressure, student, what they are saying, if the pressure is high, so pressure is high, they are saying when the pressure exceeds the saturated pressure, so become independent of P values. Okay, so pressure is very high, so the extent of adsorption is constant. It is not depending on the pressure. So here x by m proportional to P naught. So P naught is 0, so x by m equal to k. So at high pressure it is constant. And last is at intermediate pressure. So at intermediate pressure they are saying x by m, that is extent of adsorption, depend on the P raised to the power between 0 and n 1. This relationship is known as Friendly's adsorption isotherm. So x by m proportional to P 1 by n. Okay, so n is greater than 1, so you can take the log, student. So if you are taking the log, student, log x by m equal to log k plus 1 by n log p. So if you are plotting the graph, student, you will find that is at intermediate pressure you will get the straight line. Okay, so this is what is the, you can correlate with equal to the linear equation y equal to mx plus c, student. Now let us move to 5.6. So 5.6, student, what the question they are saying, what do you understand by attractive of adsorbent, how it is activation of adsorbents, how it is achieved. So dear student, at activation, okay, activation means you are activating the adsorbent. Okay, so how you are activating the adsorbent, student, that is by activating an adsorbent we tend to increase the adsorbing power of the adsorbent. Some way to increase the activate an adsorbent is there. What is there, student? First point, by increasing the surface area of the adsorbent, this can be done by the breaking into the small pieces or the powder it. So when you are making the powder of the adsorbent, you will find the greater surface area will be there, student, and if greater surface area will be there, so that is greater adsorption will be there. Now the next point is some specific treatment can also lead to the activation of the adsorbent. For example, wood charcoal is activated by heating it between 650 Kelvin to 1330 Kelvin in vacuum or air. It expels all the gaseous adsorb or the adsorb and thus create a space for the adsorption of the gas. So what they are saying is, student, if you talk about that is, if you are heating the like that charcoal, they are heating at 650 Kelvin to 1330 Kelvin, so you will find what you will find, that is gases will get more adsorbed. Okay, and on heating there is the free space for the adsorption of gases will be created on the surface of the adsorbent. Now let us move the next point, student. What does role of adsorption play in the heterogeneous catalysis? Here, student, when you are talking about 5.7, so they are saying that is what is the role of the adsorption play in the heterogeneous catalysis. Here, student, that is in heterogeneous catalysis means gaseous particle getting adsorbed on the surface of the catalyst. Okay, so what will happen, solid catalyst, so what will happen, there will be the some steps taking place, like firstly the diffusion will take place, then diffuse, then they will form the new bond, then they will get deadsorbed, like that, then finally the reaction will complete and product will form. Let us read out the catalyst, heterogeneous catalysis. A catalysis process in which the catalyst and the reactant are present in different phases known as heterogeneous catalysis. Means reactant, product and reactant are and catalyst are different phases, that is known as heterogeneous. This heterogeneous catalysis section can be explained in terms of adsorption theory. Mechanism of catalyst involved in the following steps. So let us see, student, what are the steps are there. First step, adsorption of reactant molecule on the catalyst surface. Firstly, the gaseous molecule will adsorb on the surface of catalyst. And second space, occurrence of chemical reaction through the formation of intermediate. So between the reactant there will be the new bond formed, student. A new bond implies that new product is forming. Third step, then desorption of the product from the catalyst. So when the new bond forms, student, new product also form, that will desorb, that will remove, so that free space will be there. And last step is diffusion of product away from the catalyst. Diffusion means what is, student? The product is taking away from the catalyst little far away, so that the other gaseous particle will get adsorbed. In this process, the reactants are usually present in the gaseous and the catalyst is present in the solid state. Gaseous molecule are then adsorbed on the surface of the gas. As a concentration of a reactants on the surface of the catalyst increases, the rate of reaction also increases. In such reaction, the product have very less affinity for the rate of reaction also increases. In such reaction, the product have very less affinity for the catalyst and are quickly desorbed, therefore making the surface free for the other reactant. Now let us move, student, 5.8. So what is adsorption, or why the always adsorption is exothermic? This is quite important, student. That is two theory I explained in the during the lecture time. What are the why it is the exothermic? If you talk about it, student, the adsorption leads to decrease in the residual forces, okay, on the surface of the adsorbent. This causes a decrease in the surface energy of the adsorbent. So residual forces means residual energy. When this adsorb, student, so residual energy will be released, surface energy will be released. Therefore adsorption is always exothermic process. Now from the thermodynamics, you go and explain with the help of thermodynamics equation. Delta H of adsorption is always negative. When a gas is adsorbed on the solid surface, its movement is restricted, leading to a decrease in the entropy of a gas, that is delta S negative. Now the process is spontaneous, delta should be negative. Since delta G equal to H minus T delta S, since delta S is negative, thus delta H is to be negative to make delta G negative, hence the adsorption is always exothermic process. So you can read out from the lectures another that I explained in the that is mechanism of catalyst. There you can read out, student. Now let us move for the problem number 5.9. What they are saying, how are the colloidal solution are classified on the basis of physical state of dispersed phase and dispersion medium. Dear student, that is one thing before the beginning of this question I am also saying, that is, if the gas and gas form the homogeneous mixture, so that is they do not form the types of colloidal. If the suppose adsorbent is gaseous phase and adsorbate is also gaseous, so they will not form the colloidal solution. So now total type of the colloids is 8 type, student. What are the 8 type? Let us try to understand. One criteria for classify colloid is the physical state of the dispersed phase and dispersion medium. Depending on the type of the dispersed phase and dispersion medium, solid, liquid or gas. Therefore can be the 8 type. So gas and gas is not there, student. Now let us read out one by one. If dispersed phase are solid, 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 liquid, 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 gas, gas. And here is solid, liquid, gas, solid, liquid, gas, solid, liquid. Now solid and solid, student, they are forming the solid salt. Example is gemstone. If you are talking about solid liquid, what types of colloid will form, student? It will form the sol, not solid, student, because here is what is there, liquid is there. So sol will form, student, like the paint is there. Up if you talk about third one, student, solid into gas. So solid into gas, student, that is smoke. Solid into gas is known as smoke, student, in which some of the gaseous part, some of the solid, solid like that, solid particle like burnt solid particle get mixed with the gaseous system, so they will form the smoke. Is the example of the aerosol. Now 4 is liquid and solid. Liquid solid is example of gel, student, which is example of cheese. And 5 point is liquid, liquid, they form emulsion type of colloid, student, example is milk. And liquid gas, they form aerosol, student, that is fog is the example. Now the gas and solid, they form the solid foam, and that is example is pumice stone. And gas and liquid, they will form, student, foam, that is also known as the example is there, student, froth. So that detail I already explained in the different lecture, you can go. Question number 5.10, that is 10. Discuss the effect of pressure and temperature on the adsorption of a gas on solid. Dear student, let us firstly read out the pressure. So adsorption is the reversible process and accompanied by decrease in pressure. Therefore adsorption increases with increase in the pressure. More the pressure, student, more will be the adsorption. Okay, because the adsorption is reversible. So if you are increasing the pressure, student, so that is adsorption will increase. And effect of temperature, when you are talking about, student, adsorption is the exothermic process. So when thus the according to Le Chatelier principle, if you are increasing the temperature, so reaction will be go reverse direction, and if it is going reverse direction, student, so that is what is adsorption will decrease. So dear student, you always try to understand that is on high pressure the adsorption will increase and high temperature adsorption will decrease. And other question we will study in the next video, student. Thank you so much for watching, friends.